Okay, this is a lesson from section 2.1 for Math 120. What we see here are three different functions given three different ways. You can use ordered pairs. That would be our function f. We can use an equation, which would be our function g. And we can use a graph to represent the x and y relationship. Number one, so let's find the domain and range. The domain is nothing more than the input values, and the range are the output values. When you find the domain for f, we're going to write this. We'll write the domain as the set of numbers 1, 2, and 3. The range is going to be the set of numbers 4, 6, and 9. Looking at g, we would recognize that there are no square roots, there are no fractions, and so this domain is going to be all real numbers, as is the range for this particular function. Graphically, what you want to do is you want to project the graph onto the x-axis for the domain, and so what I can see here is that all the x values are represented on this graph. So in this case, the domain is going to be all real numbers. And when I project this graph onto the y-axis for the range, I can see that all numbers are represented as well. So in this case, the range for this function is going to be all real numbers. Number 2 asks us to find f of 3 plus g of 3. Well, f of 3 is found by looking at your ordered pairs. F of 3 is equal to 9. So if I replace f of 3 with 9, I can add that to g of 2. Well, when I look at g, it says take the input of 2 and square it. So x squared plus 3. And so doing a little arithmetic, we're going to get 9 plus 4, 16. Number 3 says find g of 2 plus h of 2. Well, g of 2 is the output when x is 2. So in this case, we'll have 2 squared plus 3. And then h of 2 is the output when h is 2 on this graph. So let's look at the graph. H of 2 is on, let's see, here's 2 on the x-axis. So here's the ordered pair, 2, 1. So we would say that 2 goes to 1. So it's going to be 2 squared plus 3 plus 1, which is 8. Sometimes they'll ask us to evaluate algebraic expressions into functions. Here's a good example. Let's take g from the previous slide and evaluate g of x plus 2. That's going to be g of x plus 2 is the same thing as I'm going to replace that x with x plus 2. G says to square the input and add 3. So in this case, if the input is x plus 2, that is the item that I'll be squaring. We're going to want to simplify this. Let's see, if I square something, that means I've got to write it times itself. And so let's FOIL. We'll get x squared plus 4x plus 4 plus the 3. Let's see, x squared plus 4x plus 7. And that would be the final answer. Down here, they're asking you to evaluate g of x plus h. Well, let's do that. We're going to do g of x plus h. In this case, we're going to be replacing, once again, that x with the input. So in this case, we square the input and add 3. The input is just x plus h. Let's do a little bit of arithmetic here. Once again, we have to square a binomial. So that means we'll take it times itself. That results in x squared plus 2xh plus h squared plus the 3. There are no like terms, and so let's finish with that line. All right, so the next item is let's review a little bit about slope, rate of change. This is information we've all seen. What we need to do is familiarize ourselves with the function notation. In this case, it's f of x2 minus f of x1, and we'll divide that by x2 minus x1. We're going to use this formula here in a little bit, but let's review a little bit about slope. Let's take y equals 3x. All right, so let's take that function. Let's see, I'll just graph it here. And remind ourselves that, let's see, an ordered pair on this graph is going to be 1, 3. I'm just taking it times 3. Another one will be 2, 6. So when I find the slope of this, we understand that this is going to be the change of the y-coordinate. In this case, it's going to be from 6 to 3, which is 3. And the change of the x-coordinate, which is going to be 2 to 1, which is just 1. And so then your slope is going to be found by taking the change of the y, which is 3, over 1. We are familiar doing this with linear functions, but let's do this with a quadratic function, all right, and see what it looks like. So what we're doing now, instead of finding a rate of change, is called the average rate of change. It's not linear. So let's find some input values here. Let's see, from x 1 to 3. So let's see, 1 is going to be 1 squared, which is just 1. All right, so 2 squared is 4. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 3 squared is way up here. So remember, this is a quadratic function. It's a parabola. It's going to be curved. And so what our rate of change looks like is from here, from 1, 1 to 1 from 1, 1 to 3, 9. These are 2 ordered pairs on my graph. So your rate of change, your average rate of change, is still looking at how much I have to rise versus how much I have to run. And so it looks like we have to rise from 1 to 9, which is 8, and we're running from 1 to 3, which is 2. So it can't be a slope because it's not a straight line. We would say my average rate of change is equal to the change of the y's, which is 8, divided by the changes of the x's, which is 2. So my average rate of change is 4. Now let's see how that looks different from a different interval. In this case, let's go from 1 to 4. We would guess that we won't get the same answer since our line is not straight, and we'll verify that now. All right, so let me give us a scale. Let's see, we'll go 1, 2, 3, 4. Now I gotta go to 16 here, so let's go 2, 4, 6, 8, 10, 12. All right, so 2. So I'm still starting at 1, 1. Let's see, 3 squared is your 9, and then 4 squared is your 16. So I still have a parabola shape, and instead of doing the rate of change from 1 to 3, I am now looking at from 1, this should be 1, 1, to 4, 16. So your average rate of change is a straight line that connects these 2 points. And so I'm going to calculate, I'm going to look at how much it changes vertically versus how much it changes horizontally. Let's see, it looks like we're going from 16 to 1, which is 15, and then 4 to 1, which is 3. So I would say my average rate of change is going to be a change of y, which is 15, over the change of x, which is 3, and my average rate of change is 5. Notice the difference. We get a different answer because it's not linear. If I go back to my prior example here of y equals 3x, if we would have done, let's say, 3, 9, I would still have gotten the same rate of change. I would go, let's go this way. I'm going to be rising 6, running 2, and because it's linear, I still get the same ratio, 6 to 2, 3 to 1. But with a nonlinear function, the interval is going to change your average rate of change values. Now, let's look at this in general. All right, let's take a look at rate of change in general. So what we have to do is take some function x, it doesn't matter, and let's take 2 ordered pairs. What we want to do here is call this the point x, and this point right here then will be x f of x. All right, And so the average rate of change is actually a straight line connecting these two, and we're going to find the slope of that line. Well, one way we can do this is we can find another ordered pair. Let's see, once again, this is x, and let's add on a value of h. Let's call this h here. And so that this is your x plus h. Well, let's see. So the ordered pair identified up here is going to be x plus h, then f of x plus h. All right, so with these two ordered pairs, we should be able to find the slope, or in this case, the average rate of change. So let's see, let's do that. The average rate of change and using our prior examples, it should make it easy. We're going to find, let's see, what did we do here? We took the 16 minus the 1 to get the 15. That's a change of the vertical length. So in this case, we'll be taking f of x of h minus your other y coordinate, which is f of x, and we'll divide that by the difference of your x coordinates. And so look here, we have x plus h and x, so that's going to be x plus h minus x. So what we want to notice here is that a nice thing happens. The x's go away, and you get a much cleaner formula for the average rate of change. Let's take a look. It's going to be f of x plus h minus f of x all over h. So this gives us a general way to find our average rate of change for any particular function. Okay, so what we just found was a formula that is known as the difference quotient. It's right here. Notice that they're using a instead of x. So let's be consistent here. We could call this f of x plus h minus f of x all over h. All right. So let's use this formula now to find the difference quotient or average rate of change for particular functions. You notice here that we have two polynomials. When I have a polynomial, a vertical organization will be advantageous. For example, what I want to do first is find f of x plus h. All right. Here, let's just write a formula over here. It's f of x plus h minus f of x all over h. So the first thing I'm going to do is compute that term. Well, in this case, we're going to get 2 times x plus h minus 1. And simplifying this, I'll get 2x plus 2h minus 1. And then let's look at subtracting this f of x. So what's going to happen here, if I take away f of x, I'm taking away both these terms. And it's nice because what happens here is you should have each of those terms cancel. So if I subtract the 2x, subtract the negative 1, all I'm left with is your 2h. And that is the difference of f of x plus h minus f of x. I still have to do one more thing. I've got to divide by the h. So let's do that. If I divide this by the h, I'll get 2, and that is my difference quotient. Not surprising here, we get the slope. The slope of this line is 2, and that's exactly what we found. The second example here, it looks like a quadratic. So it's a polynomial, so let's keep that same organization. F of x equals, let's see, it'll be, that's not what I want. The first thing I'll do is I'll find f of x plus h. Let's see, we're going to square x plus h squared plus x plus h. We can square this by foiling it out. We'll get 2xh plus h squared plus x plus h. Look at these like terms here. I'll get 2x and x. Sorry, those aren't like terms. There are no like terms to add. The next thing I'll do is I'll subtract f of x. Once again, I just found this guy right here. I'm going to subtract f of x. And with a polynomial, you should have every term from f of x cancel with your product you just found. So take away x squared, take away an x, and what you're going to be left with is the difference. So we get 2xh plus h squared plus h. Now, this is something a lot of students forget, but we still have to divide by the h. So let's do that. After we divide by the h, we will be done. Let's divide by h, and what's going to happen here is every term should have an h in it, so let's factor that out. We get h times 2x plus h plus 1, and dividing that by the h lets me cancel it out. So then my difference quotient is 2x plus h plus 1. That is my final answer. All right, let's take a look at the difference quotient for other functions, such as a rational function. In this case, it's going to you're going to want to do the top in one step. So f of x plus h minus f of x. So what we're going to do here is we're going to replace the x with x plus h, and then we'll subtract 7 over x plus 6. What we need now is a common denominator. The LCD in this case is going to be multiplying these together, x plus h plus 6 times x plus 6. When I multiply the left fraction by that, let's see what we get. We're going to get 7 times x plus 6 all over x plus h times x plus 6 minus 7 times x plus h plus 6 all over x plus 6 times x plus h plus 6. It looks like I'm going to run out of time, class. Let me do this. Let me stop the recording here, and I'll make a new recording for this next part.